Hello, dear students. Today we are going to solve 2018 May-June 2-1 paper. The course is Physics 5054. It's a theory paper. We call it paper 2. The variant is 1. Okay, on your screen you can see question number 1. And just to remind you that today we will be only solving the section A. We will solve section B in another video. Okay, let's start. Question number 1 is on your screen. A cyclist travels along a straight horizontal road as shown in the figure 1.1. You can see a cyclist. He will be traveling on a straight road, horizontal road. Describe how the average speed of the cyclist can be measured in your account. Suggest what equipment is used, the measurements that are made, and how the average speed is calculated. Okay, to calculate the average speed of anybody, you need to know two things. One, how much distance is covered and how much time is taken to cover that distance. For measuring how much distance is covered, you mark the starting point and the end point, and then with the help of measuring tape or with the help of trundle wheel, you can TRUNDLE trundle wheel, you can measure the length of the path, the distance between the starting point and the finish point, and then with the help of the stopwatch, you can measure how much time is taken from moving from starting point to end point. And then you divide the distance with the time taken, and you will be able to calculate the average speed. I have written this answer, and let me show you that. Question number 1A part is on your screen. Measure the distance between the starting point and the finish point with the help of a measuring tape. Use a stopwatch to measure time taken to complete this journey. To calculate speed, divide distance with time. This is a 3-mark question. I think it's clear to you. Now let's move to the next part. Is the B part of the question number 1. For what part of the journey the cyclist has a constant for the part of the journey, the cyclist has a constant negative acceleration. State what is meant by a negative acceleration. So it's 1-mark question. We have to define what is negative acceleration. And the second part is the size of the acceleration is 1.8 meter per second square. Calculate the change in the speed of the cyclist in time of 2.5 seconds. It's a 2-mark part. Okay, we will answer both of these. I have done this. You see, the negative acceleration means we call it, we have a proper name for negative acceleration. We call it retardation. We also call it deceleration. And retardation or deceleration or negative acceleration means that the velocity is gradually decreasing. So negative acceleration is decrease in velocity per unit time. The proper definition is negative acceleration or deceleration or retardation is decrease in velocity per unit time. The second part was the acceleration was given 1.8 meter per second square. The time was given 2.5 seconds. The question was how much is there in change in velocity. You know that the acceleration is equals to change in velocity divided by time. So we know the value of the acceleration, we know the value of the time. So 1.8 equals to change in velocity divided by 2.5. This delta V stands for the change in velocity. So change in velocity will be 1.8 multiplied 2.5, and the answer will be 4.5 meter per second. So I hope that this was the whole question number 1. It's done. I hope it is clear to you. Okay, let's move to the next question. On your screen, we have question number 2. Figure 2.1 shows a man pushing a heavy box with a force P, a frictional force F acts in a horizontal direction. The force on the box are balanced and the box is stationary. State what is meant by balanced force. You see this man is applying force P in the forward direction to the right, and the frictional force is in the backward direction towards the left. And he's asking us what is meant by the balanced forces. If the forces are acting on the body, they are in opposite in direction, they are equal in magnitude, their sum will be 0, their resultant force will be 0. So we will say that the forces are balanced. I have written this answer also. Let me show you. Question number 2, part A, is on your screen. If the sum of all the forces acting on a body is 0, forces are called balanced forces. It was a 1-mark question. Okay, let's move to the next part. In the second part, he says the friction force in figure 2.1 does not produce any heating effect. State what must happen for the frictional force to produce heating. Once the body will start moving against the frictional force, then the heat will produce. Okay, I have written this answer also. Let me show you. Question number A, part 2, is on your screen. For frictional force to produce heat, the body must slide against the frictional force. It's a 1-mark question. I hope you understand these sentences. Question number 2, part A, part 3. Apart from being stationary, describe one other possible state of motion of the box when the two forces are balanced. You see, if the forces are balanced, then there can be two situations. If the body was at rest and the forces are balanced, the body will remain at rest. So this is the situation here. He's asking for the other condition, other scenario. If the forces are balanced and the body was moving with a certain speed, suppose, then what will happen when the forces will become balanced, the resultant force will be 0, then the body will continue moving with that constant velocity. So the second scenario is that if the forces are balanced, the second option can be that the body will move with a constant velocity. Let me show you its written answer also. Question number A, part 3. If forces acting on a body are balanced, it will continue moving with constant velocity. It was a 1-mark part, so I hope you have understood it. Okay, so we are moving to question number 2. It's B part. He says, when the P force is 100 Newton and the F force is 85 Newton, the box accelerates. The mass of the box is 25 kg. Calculate the acceleration of the box. You see, these forces, the P force is given, the F force is given, subtract them from each other, you will get the resultant force. The forward force P is 100 Newton. The backward force is 85 Newton. To get the resultant force, P minus F. Apply that formula, 100 minus 85, and it will give you 15 Newton. So the resultant force is 15 Newton. We know the mass of the box, which is 25 kg. By applying Newton's second law of motion, its mathematical equation is F is equals to ma. The resultant force we know is 15. The mass is 25. A is question. So A will be F divided by m. Just put the value, you can get the answer. I have done this on a paper. Let me show you that. On your screen, you can see B. Resultant force is P minus F. 100 minus 85 equals to 15 Newton. M is 25 kg. F is equals to ma. A will be equals to F divided by m. F resultant force is 15 divided by 25 kg equals to 0.6 meter per second square. So the acceleration is 0.6 meter per second square. This was a 3 marks numerical. It's easy. I hope you have understood it. Okay, so we are moving to the next question. Next question is question number 3 on your screen. A passenger in an aircraft closes a plastic bag with some air inside as shown in the figure 3.1. A part is explain how the molecules of air in the bag exert a pressure on the inside of the bag. You see, this plastic bag has air inside it. The air molecules are randomly moving. When they are moving in all directions, what happens during their motion? They collide with the walls of the bag. And when they collide with the walls of this bag, they exert force when they collide with the wall of the bag. So when the molecules are colliding with the walls of the bag, they are exerting force on the walls of the bag, and that force per unit area will be creating pressure of the gas inside the bag. So it's a 2-mark question. Let me show you my written work also. Here, question number 3, A part is on your screen. Molecules of air inside the bag are moving randomly. They collide with each other and with walls of bag. When they collide with walls, they exert force on it. This force exerted on per unit area of walls is pressure of air. It's a 2-mark question. I hope it's very simple, straightforward. You understand. It's a famous concept being asked again and again in the paper. Okay, B part is on your screen. When the bag is closed, the pressure of the air inside the aircraft is 80 kilopascal, and the bag contains 500 cubic centimeter of air. First part is when the aircraft is on the ground, the pressure of the air inside the aircraft is 100 kilopascal. Calculate the volume of the air inside the bag when the aircraft is on the ground. You know, he's talking about the air, which is gas, and he talks about pressure, volume, again pressure, and what is the volume. We suppose we can apply the formula P1 V1 equals to P2 V2. P1 is 80 kilopascal, V1 is 500, and the P2 is 100 kilopascal, and V2 is question. So very simple, 2 marks numerical. I have done is working. B first part is on your screen. You can see P1 V1 equals to P2 V2. 80 into 500 is equals to 100 into V2. V2 is a question. So take this 100 to the other side, do the calculation. The answer will be 400 cubic centimeter. It's a 2 marks numerical, simple, straightforward, famous concept. I hope you have understood this numerical. Let's move to the second part of this B part. State 2 assumption that you made in your calculation. You know the formula which we have applied, P1 V1. Let me show you, make the size a little bit smaller so that everything is visible. Okay. In the B part, when I did this, I used the formula P1 V1 equals to P2 V2 for the gas, pressure, and volume. This formula, when we apply this formula, we make some assumptions. The first assumption we made is that the temperature of the condition, the temperature of the gas in the first situation and in the second situation remained constant. That's the first assumption we make when we apply this formula. The second assumption is that we assume that the mass of the gas inside the bag is fixed. It means the mass and the number of the molecules of the gas in the first situation and the mass and the number of molecules of the gas in the second situation are same. So the mass of the gas is fixed. These are the 2 assumptions we have made. It means that none of the gas has escaped during our experiment. So we have made 2 assumptions. B part, second portion. Temperature of the air is constant and the mass of gas inside bag remains constant. These are the 2 assumptions we have made. So this was question number 3. I hope it is clear to you. Okay, so we are moving to the next question. The next question is question number 4 is on your screen. He says, a woman does work as she raises a flag by pulling downward on a rope. This is shown in the figure 4.1. And so what she's doing, she's pulling the rope and the flag is going up. Okay. So the first question is, A part is, define what is meant by the work done. It's a 2-mark question. We have to define what is work done. You see, when a force is applied on a body and the body starts moving, if you apply force and body starts moving, then if you multiply the applied force and the distance traveled in the direction of the force, the product will be equals to the work done. So I have written this answer also. Let me show you. Question number 4, A part. If force is applied on a body and body moves, the product of applied force and distance traveled in the direction of force is called work done. It's a 2-mark definition. I hope it is clear to you. Okay, let's move to the next part. On your screen, you can see sorry, The mass of the flag is 0.35 kg and the flag is raised to a height of 3 meter. The gravitational field strength G is 10 Newton per kg. Calculate the increase in the gravitational potential energy of the flag. You know, the increase in the gravitational and the potential energy can be found by the formula mgh. Gravitational potential energy is equal to mgh. M is given 0.35 kg, G is given 10 Newton per kg, and the height is given that 6 meter. So simply multiply them. You will be able to find out the increase in the gravitation. I have done this numerical also. On your screen, can you see question number 4, B part? Increase in the gravitational potential energy is equal to mgh, 0.35 into 10 into 6, and the answer will be 21 joules. It's a 2-mark numerical, a famous concept on which numericals come in paper. I hope it is clear to you. Okay, so we are moving to the next part, which is question number 4, C part. Suggest and explain a reason why the work done on the rope is larger than the value calculated in the B part. In the B part, where we calculated the work done, it was 21 joules, and we only used the mass of the flag. He says the actual work done is more than the 21 joules. Why? Because you see, when she was pulling the rope, she also has to lift the weight of the rope. She also has to overcome the friction. There might be friction between the pulley and the rope. And when she applied the force, that her energy, some of her energy might have been converted into heat, which would have lost. So she has to overcome that friction also. So the actual work done by her is more than 21 joules. I have written this answer also. Work done on rope is larger than 21 joules because girl has to lift rope and there might be friction between rope and pulley, due to which energy will be converted into heat. It's a 2-mark question, very simple and straightforward question. This was question number 4. I hope you have understood it. Now we are moving to question number 5. On your screen, question number 5, a student has 3 resistors. Each resistor is labeled 3.9 ohm, 3 watt. She checks the value of the resistance of one of the resistors. In the space below, draw a circuit diagram of a circuit that she can use to find this resistance. Include a battery, a variable resistor, a voltmeter, and an ammeter in the circuit. It's a 2-mark question. We have to draw the circuit. Okay, I have done this. So on your screen, can you see on your screen, here is the battery, and I have connected an ammeter. This is the symbol for the ammeter. In series, I have connected a variable resistor. Its resistance we can change. Then I have connected that resistor, whose resistance I want to find out. And then I have connected back into the battery. Parallel to this resistor, I have connected a voltmeter. So this is the circuit diagram which we will require if we want to find out the resistance of that resistor. I hope you are able to understand this circuit diagram. It's a 2-mark question. Okay, we are moving to the next part. When the circuit is turned on, B part, this is the B part. When the circuit is turned on, the potential difference across the resistor is 4.2 volt, and the current in the resistor is 1.2 amp. Calculate the resistance of the resistor. You see, the voltage is given, the current is given, the resistance is question. You know, V equals IR. V equal IR. If you want to find out R will be equals to V divided by I. The voltage is given 4.2 volt. The current is given 1.2 amp. Just divide them, get the answer. It's a 2 marks numerical. I have done this. Let me show you my working. R is equals to V divided by I equals to 4.2 volt divided by 1.2 amp equals to 3.5 ohm. So the resistance will be 3.5 ohm. Okay, it's a simple question. Okay, shortly after the circuit is turned on, the resistance overheats and give off smoke. Explain why it overheats. Include a calculation in your answer. You remember, in the start of the question, he told us that the power rating of this resistor is 3 watt. So it can only bear a power of 3 watt. It's 2 marks question. I have written this answer. So what we have done here, power rating of the resistor is 3 watt. That was given in the question, at the first in the first sentence. Power provided to the resistor is P is equals to IV. The I is 1.2 amps and the voltage you provided is 4.2. So the power you are providing is 5.04 watt. You see, the power rating of the resistor was only 3 watts, but you gave it a power of 5.04 watt. It is way higher the power it can bear. So what will happen? You have provided too much. So due to the heating effect of the current, the resistor will burst. It will melt. It will get fire. It will blow. Okay, so it's a 2 mark question. You see, he asked us in the question to include the calculations. So we have done that. Okay. So the next question is the third part now. And he says the other 2 resistors are also labeled 3.9 ohm, 3 watt. The first resistor is now removed and the student connects these two resistors in series to the potential difference of 4.2 volt. State and explain whether these resistors overheat. Now what we have done, we have connected 2 3.9 ohm resistors in series with each other and we connected them with a battery of 4.2 volt. So now what will happen? Okay, no, I have not written its answer. I'm sorry, but I can tell you now, because you have connected it. Let me, yeah. When you have connected 2 resistors, 3.9 ohm resistors, in series with each other, so their total resistance will be 3.9 plus 3.9 equals to 7.8 ohm. Now calculate how much current is coming from the battery. The current coming from the battery can be calculated by the formula I is equals to V divided by R, where V is the EMF of the battery, which is 4.2 divided by the total resistance of the circuit. That will be 7.8. So 4.2 divided by 7.8, you will get a current of 0.538 amp. 0.538 amp. So now we can calculate how much power is provided to one resistor. The power provided to one resistor can be found by the formula P is equals to IV. P is equals to IV. So the power is 0.538 multiplied 2.1 and the answer will be 1.13 watt. So now the power provided to each resistor is only 1.13 watt. So the power provided is less than the power rating of the resistor, which was 3 watt. So that's why now the resistors will not blow or overheat. I hope it is clear to you. And I will, let's move to the next question. Question number 6 is on your screen. A steel rod is magnetized using an electrical method. Describe how this is done. You may draw a diagram if you wish. You remember, if you want to magnetize, we use DC power supply or a DC battery. We take the steel rod, we wind a copper wire around it, and when we connect it with the DC power supply, that steel will become magnetized. It's a 2-mark question, and I have done this on a paper. Let me show you my working. Okay, here you see, yeah, the question number 6A part is right now on your screen. It says, can you see that diagram? I have a steel bar, then I have taken a copper wire, I have wound the copper wire around the steel bar, I connected the copper wire with the DC power supply, and when you will switch on the current, this steel bar will magnetize. Give it some time, and this steel bar will become magnetized. Okay, so when a large direct current flows through coils of a wire, which we call a solenoid, a strong magnetic field is produced. The magnetic field aligns the magnetic domains in the steel bar. After a period of time, the steel bar will be magnetized. It's a two-mark question. I hope it's clear to you, the wording, how we write the answer, how the diagram is made. It was easy. Okay, so we are moving to the next question. It's a two-mark question again. It's question number 6b part. Describe how you can check the steel rod is magnetized. If you want to check that steel rod is magnetized, suppose, for example, let's say this is that steel rod which is magnetized, and suppose this is its one end, this is its right end. Suppose it's right end. Take another magnet, bring that magnet's north pole here. Suppose it is attracted to this. Then bring the south pole of that magnet, and if it is repelled, you see, one of the poles should be repelled by one of its steel rods end. If they are repelled, then we can say that the steel rod is magnetized. You know, the repulsion from one of the poles of a permanent magnet is a confirmed test that the steel rod is magnetized. Remember, attraction with another magnet is not the confirmed test for it to be magnetized. Repulsion, repulsion is the confirmed test that this is magnetized. If one of its end is repelled by another pole of a magnet, then it will be a confirmed test that this steel rod is magnetized. So repulsion is a confirmed test. Let me read you the answer which I have written on your screen. You can see question number, I have this question number 6b part. One end of the steel bar should be repelled by one of the poles of another permanent magnet. Magnetic repulsion is the only test to confirm whether an object is a magnet or not. I hope you understand. Okay, so now we are moving to question number 7. Question number 7 is on your screen. Electrostatics can be a nuisance, but it is also useful. A part, a person walks across a carpet. As he touches a door handle, he receives an electric shock. Suggest why this happened. You see, when you walk on a carpet, due to the friction between your feet or your sneakers and the carpet, due to that friction, the transfer of electrons will take place. Maybe from your body, the electrons are transferred to the carpet, or maybe from carpet, the electrons are transferred to you. But whenever you walk on the carpet, there will be, due to the friction, there will be a transfer of electrons between your body and the carpet. So what will happen? Your body will become charged. It might become positively charged. If it loses electron, it might become negatively charged if it gains electrons. So now the point is that your body is charged. So what happens when you go and you touch the door handle? You come in contact with the earth, your body. So what will happen? If you are charged body, then the electrons will transfer from you to the earth, or from earth through that door handle to your body to neutralize you. So a transfer of electrons will take place between your body and the door handle to neutralize your body. And when this will happen, you will feel an electric shock. Okay, so this is a 2-mark question. I have written this answer. I tried to write this answer also. So you can see question number 7a part. When a person walks on carpet due to friction between his feet and carpet, transfer of electrons takes place and he becomes charged. When he touches the door handle, again, transfer of electron takes place to neutralize him. Due to this transfer of electrons, he get an electric shock. So it's a 2 marks question. I hope this story, this answer, this question, the whole thing is clear to you. Okay, on your screen, question number 7b part. In a spray painting, small drops of paint from with a positive charge emerge from a nozzle. The drops are used to paint the leg of a metal chair, which has a negative charge as shown in figure 7.1. So you see what is happening here. The paint drops are coming out and they are coming, the nozzle is positively charged, so the oil droplets will have positive charge and they are spreading around this leg, and that leg of the chair is negatively charged. Okay, the figure 7.2 shows what happens when there is no charge on the nozzle or on the drops or on the leg of the chair. So this is a situation in which the paint is coming out, the droplets of paints are coming out, but they are not charged. This nozzle is not charged, the droplets are not charged, this leg of the chair is not charged. But in the 7.1 figure, the droplets were positively charged, the leg was negatively charged. But here, neither the leg nor the droplets are charged. I hope you understand this story. Okay. The question is, the drops in the figure 7.1 spread out more as they leave the nozzle than those in the figure 7.2. Explain why. The drops in the figure 7.1, which were positively charged, why they spread out? You know, because the droplets of the paint, they were positively charged. And you know that the like charges repel each other. All the droplets of paint, they all were positively charged. So they were like charges. So they are repelling each other. That's why they will spread out. So it's a 2 marks question. Let me read you the answer. B first part, question number 7. In figure 7.1, drops of paint are positively charged, so they repel each other. That is why they spread out more as compared to the paint droplets in figure 7.2, which are neutral. It's a 2 mark question. I hope you have understood this answer. Next question is, explain why the paint reaches the back of the leg in the figure 7.1. You see, in figure 7.1, the paint droplets who pass the leg, then they turn and they come on this side and they are attached with the leg. Why? The question is why. The reason is that the droplets are positively charged and the leg is negatively charged. So these opposite charges are attracting each other. That's why these droplets, even though they have crossed the leg, but they turned in the air and then they attach themselves with the leg. So the reason is that both of them are opposite charge. So the charged droplets are positively charged, the leg is negative, so they attract each other. So I have written the answer also. This is on your screen. Positively charged paint droplets are attracted to negatively charged leg. It's a 1 mark question. I hope it is clear to you. So here on your screen, you can see figure 8.1 shows a transformer connecting an overhead 24,000 volt electric power line to a house. You see, this transmission line is bringing in the current and the voltage is 25,000 volt. And here we have a transformer, and this transformer is supplying the electricity to your home. So this transformer, what it will do, because you know the electricity, when it is transmitted to homes, when we bring this electricity to our homes, the electricity is only on 220 volt normally in Pakistan. And what will happen that this transformer which is here, this transformer should be a step down transformer. So what this step down transformer will do, it will reduce the voltage. So it's a step down transformer. His question is state whether coil A or coil B in the transformer has a larger number of turns. Give a reason for your answer. You know, it's a step down transformer. It's a step down transformer. This coil A is the primary coil. It has 25,000 volt. And the secondary coil is coil B, which will be giving us a very small amount of the voltage as compared to the primary voltage. So the number of coils in the B should be less. The number of coils in the A should be more than the coil B because it is a step down transformer. I have written this answer. Question number 8. This transformer is step down transformer. Its function is to reduce voltage. To do this, number of turns on coil A, which is primary coil, are more than the number of turns in the coil B, which is secondary coil. Okay, let's move to the next part, B part. He says one purpose of using an iron core in the transformer is to increase the magnetic field inside the coil A. State one other purpose of using the iron core. Very simple. What the iron core do, it provides the path for the magnetic field lines from the primary coil to the secondary coil, or it links the magnetic flux of the primary coil with the secondary coil. So I have written this answer also. Let me read that answer. B part is iron core provide path for magnetic field lines from coil A to coil B. It's a 1-mark question. I hope it's clear to you. Okay, we are moving to next part, C part. Describe briefly how an output voltage is induced in the coil B. You see, a famous question. You have provided the primary coil with an alternating current. And due to that alternating current in the primary coil, whose name is A, a magnetic field is created, a magnetic flux is created due to that alternating current. The magnetic flux which is created, it is changing. Its direction is changing, its magnitude is changing. And by the iron core, that magnetic flux is passing through the coil B. So that magnetic flux, the changing magnetic flux is passing through the coil B. Due to that changing magnetic flux passing through the coil B, an EMF is induced in the coil B. I have written this answer also. Let me read this for you. C part. AC supply in coil A creates a changing magnetic field in coil A. This changing magnetic flux passes through coil B with help of the iron core. Due to changing magnetic flux, EMF is induced in the coil B. I hope you understand. Okay, so D part is on your screen. Suggest one advantage and one disadvantage of burying a power line underground rather than having an overhead power line. You know, we in our hometown, we all have the transmission lines. They are overhead. We have poles, electric poles, and on them we have the transmission lines. But he is talking about another idea. Why not the transmission lines, we place them underground? So the question is, what is the advantage of putting them underground? You see, if the electric lines are underground, they will be safe from the effect of storms or wind or rain. Less chances are there for electrocution. Disadvantage of putting them underground is that if a fault is created in the transmission lines which are underground, then to detect where is the fault will be difficult, and then to repair that fault will be difficult because first you have to dig the wire out. So every time you have to do the repair, you have to dig them out. So that's the disadvantage. I have written this answer on a paper. Let me read it for you. The advantage is less likely to be damaged by storm or wind. And the disadvantage is difficulty in repairing once a fault is produced. It was a 1-mark question. This is question number 8. I hope that I have made my point clear to you, and you are able to understand. I hope that. One thing, if you have a hard copy of this paper in front of you and you are watching this video and you are writing the answers, and then it will be very beneficial for you. But if you don't have a hard copy, even then it will be beneficial. But if you have a hard copy of that paper, a copy of that paper in front of you, and you're writing on that paper, then it will be very beneficial for you. uh, there was a question today, question number 5, and it's B part, and we just missed the uh, I just I was not able to put its figure in the computer. I just missed it. And let me show you that. If I think through the camera, is it possible? If it's possible, I don't know. Can you see that? Maybe you are able to see it. You see, on this page, you might be able to see, I don't know. I'm trying that you might be able to see that calculation, or at the bottom of the page, that calculation is done. Okay. Okay, anyway, I have told you how that calculation was done, and I hope that it was useful to you. And this was, everybody, this was May June 2018 paper 2-1. Is the course is Physics 5054, and I have done my best. I have intentions are that you are sitting at your home, you might be able to understand this paper, and please keep on doing hard work, and I believe that you will excel. Your answering skills in physics will improve. Thank you very much, everybody, and have a good day. And thank you very much. God bless you.